In this video, we will talk about tracing in a schematic view by using Verdi 2017.03. Now let's see what you can expect to learn from this video. Firstly, we will talk about how to isolate the concern logics from a complex schematic and then trace it incrementally. Then we will see how to view the module boundaries in a flattened schematic view. Then we will see how the signals connect to different modules. Assuming we are now debugging a get-level netlist and like to trace the connectivity, comparing to debugging the source code view, usually it will be easier to view the connection in the schematic view. In Verdi, the fastest way to open the schematic view is to click this new schematic icon. This will open the schematic view for current scope, but it may bring us a very complex logic since it's a netlist. In this case, we would like to start with an empty schematic view first, then trace the connection incrementally. Let's see how to do that in Verdi. Firstly, we can open the Hierarchical Flatten View. If you don't select any object in the source code view, then you can go to the Tools, New Schematic from Source, and then select this Hierarchical Flatten View. In Verdi, we can easily change the layout to get better working space. Let's change the position of this schematic view so it can better correlate with source code. Now we want to start debugging from this U250 instance. We can select this one, then drag and drop it from the source code to the schematic view. The instance has been added to the schematic view. We can see the hierarchy boundary of this instance. It means the instance is under the ALUB scope. We can now start debugging from here. For example, if you like to see the driver of the input pin, you can just double-click the input pin to expand the connection. As you can see, the schematic view tells you that the driver comes from a register output, and it's from another module scope. You can see the module name in the upper left of the boundary. Besides tracing driver, we can do some other tracing in this view. For example, let's trace the fanning cone of this instance. We can select it, and then invoke the trace fanning cone. The fanning cone will trace passing through combinational logics until reaching the register output. Now you know how the fanning cone came from other scope and then drives this instance. The object in the schematic view can be removed if you don't need it. For example, you can select the instance and press delete. Then it will be removed from this schematic view. You can also select the module boundaries and then press delete to remove the whole scope. The schematic view also provides some more advanced tracing. For example, now we like to trace the fanning cone across multiple levels. Let's select Trace by Level. We can trace the fanning cone of a signal over 2 levels of registers. Let's see how to do it. Let's select the fanning in the trace mode and then specify 2 for the level number. It means we want to trace by crossing 2 register levels, and then press OK. Now we know how the fanning cone crossing flip-flops then drives the instance. If you feel the logic seems a little messy due to the color, you can set the high contrast mode to focus on viewing boundaries. This schematic view can also be used to have a quick overview about how the signal connects to different modules. For example, we are now interested on how the system clock drives different scopes. Let's go to the system scope and then select the clock signal. Then we can simply invoke the schematic view. Now we can easily understand how the clock signal drives different scopes and can have a quick overview of the clock tree topology. Now let's see what we had learned from this video. Firstly, we had learned how to open the hierarchical flatten view from the source code view. Then we learned how to drag and drop to add objects and debug it incrementally. Then we had talked about how to perform some advanced tracing like fanning cone in the schematic view. Finally, we understand how the signal connects to different modules from a flattened schematic view. This is the end of the video. Thank you for your time.